So in section 5.4, we're looking at what's called the general factoring approach, which just throws all of our processes together. We pretty much have talked through all of this already. The idea of looking for a GCF as the first step, then identifying what you're working with. If you're working with a binomial, we have our form that we just learned, difference of squares. If we're looking at a trinomial, it says to check if it's a perfect square, which again came from section 5.3. That's optional. You really can just, if you aren't feeling that, you can just say, is it an easy case number game or a bottoms up approach from 5.2? You can jump right to that. So more than 3 terms, or for this class, meaning 4 terms, we can try grouping, right? We talked about how grouping may not work, but we can try it. If it doesn't work, we can swap the middle terms and try it again. But that's effectively your factoring checklist. And then it just reminds you that you can always check your final factored form by multiplying. So just seeing some questions, nothing really technically new here, just a question of going into these problems not knowing which section we're in, so considering which approach to use. So to factor it, first step, always GCF. In this case, it's a 1. And so it's 2 terms with a minus, which means if anything, it's going to be a difference of squares. Meaning the question of what would you square to get 36x squared, which is 6x? What would you square to get y squared, which is y? And then knowing our formula of a plus b minus b, giving us 6x plus y times 6x minus y. And done. Nothing fancy there. Next one. We see a t squared t no t, so we see a trinomial. But first step, GCF of 1 doesn't help us. Since it's t squared t no t with something other than a 1 out front, we're going to have to use our bottoms up approach. So off to the side, we take a times c, a times 5, get our 40. Then we look for the factors of 40. 1 and 40, 2 and 20, 3 and nothing, 4 and 10, 5 and 8, and 6 and nothing, and 7 and nothing, so we're done. So there's our factors of 40. We want factors that multiply to a positive 40 and add to a negative 13. Well, to do that, we need both negatives, and specifically, we would need negative 5 and negative 8. So I'll bring those 2 factors over here with my t minus 5 and t minus 8, and then we'll take the a value, that lead term, or lead coefficient there, throw it as a denominator. This does not reduce at all. That is just minus 5/8. Now this reduces entirely down to a minus 1. So the only bottom to bring up is that 8, giving us an 8t minus 5 there, and our factor of t minus 1 there. All right, looking at our next example. We count 1, 2, 3, 4 terms. Let's start off with our first step, GCF. Let's see, we got p's in 3 of them, but not the 4th, q's in 3 of them, but not the 4th. So GCF is a 1 there. And so with 4 terms, we'll use grouping. P cubed minus 2p q squared. Remember, always plus. And then p squared q minus 2q cubed. And so in this set of 2, we see a p in common, leaving me p squared minus 2q squared. Over here, no p's in common. We do have a q in common. So I'll pull out the q, and we're left with p squared minus 2q squared. 1 less q there. And with grouping, that is what we needed to see, right? We need to see those binomials match to factor them out as we're calling the big GCF. P squared minus 2q squared. And our other factor comes from those outside leftovers of p plus q. Now, something to keep in mind, with what we've done, we do want to check every binomial because we do have some squared stuff going on here. This is very close to being able to actually break down further. But p squared minus 2q squared, I've got the minus sign. And if I start asking that question, you can even start and ask, well, what about an a and a b for this? Well, a, the thing you square to get p squared would be a p. The thing you square to get 2q squared. You can get the q squared, but 2 isn't a perfect square. So that doesn't work, right? That's supposed to be a question mark. That doesn't work. We can't find a b that you square to get that, so we're not going to break that down any further at all. And so that is our final factored answer there. And then this last one here, 6x squared minus 3x minus 63. We'll start with the GCF, first step GCF, and there's a GCF of 3. So we'll factor that out first, getting 2x squared minus x minus 21. And at that point is our trinomial, but there's something other than a 1 out front, so we will jump into the bottoms-up approach with these two numbers. 2 times negative 21, give me negative 42, and then factors of 42. 1 and 42, 2 and 21, and 6 and 7. And then looking for factors of negative 42 that add to negative 1, which would be a positive 6 and a negative 7. Coming back over here with those two numbers, x plus 6, x minus 7, but then putting them over that value of a, over the 2, reducing, which that reduces completely. This doesn't reduce at all. And so that's the only bottom we have to bring up. So we have this factor of x plus 3, that factor of 2x minus 7, and then we don't want to forget our GCF out front of a 3, giving us our final factored form there.